Short video. I'm going to show you how we can use the Excel software to solve complex linear programming or optimization. Okay, so to do this initially, we're going to be using a program called the Solver tool. It's an Excel add-in, and in order to do that on a Mac, you'd have to go to your tools and click on Excel add-ins and then activate it. And I think in Windows you would have to you'd click on the Excel home button and add the Solver add-in. Okay, so let's go back to our problem that we've been working with this week, and what we want to do is we want to use Excel to solve our gas processing problem, and in order to do that we're going to have to enter our table into Excel and set constraints and optimize our solution. Okay, so let's start by setting up the table. So let's call it the gas processing problem. Okay, I'm just going to make this bold. All right. Okay, and we've got the regular product, regular, premium, okay, we've got the amount produced, and we said that was in this would vary depending on if we're looking at time or storage. So we'll add that later. Okay. And we've got the raw gas production, which is in cubic meters per ton. Okay. And we said that was for the regular gas 7 cubic meters per ton, and for the premium 11. Okay. Then we had the production time, and this is in hours per ton. Let's just put this in the cell. In hours per ton, and we said for the regular it took us 10 hours per ton, and for the premium it took us 8. Then we had our overall storage in tons. Okay, we could store, we could store 9 tons of regular and 6 tons of the premium. All right, and then we had our, this might be easier actually if we write this in terms of storage premium, regular, and you'll see why I'm writing it like this now. Okay, so let's just delete this. All right, storage regular and storage premium. So what I'm doing is I'm delineating the two storages. Okay. Then we had our unit profit, so we would make 150 something per ton of regular and 175 per something of ton of the premium. Okay, so now I'm going to add these columns. I'm going to call this total and available. Okay, so available is going to limit my solution, and this is important. All right, so of the raw, the total amount available, or the resource availability for the premium and regular, is 77 cubic meters per ton. All right, and the amount of time that we have to make both products is 80 hours per ton. All right, and I can only store 9 tons of the regular product and 6 tons of the premium product. So that's my storage availability. Okay, so what is the total? All right, so we've got this amount produced here. So let's call this in value ton. All right, so at the moment we haven't got anything produced, but our total here, so the total cubic meters of both the regular and premium produced, and we're going to enter the Excel formula, is equal to the 7 cubic meters per ton multiplied by the amount produced. That's for regular, and we do the same for the premium. Okay. All right, and for the production time per ton, do the same thing. So let's equal to our production time rate plus that for premium. Okay, and we've got the total amount in tons of regular, which is equal to our produced value, and for premium. Okay, and then we've also have our unit profit. So if we had a total profit, so this is profit, the unit profit is obviously profit per ton. So if we go unit profit multiplied by the tonnage produced for each gas, then we can figure out our total profit. Okay, and this equals the sum of these two for our total profit, because we're in the total column here. Okay, so now we've set up cell references and some basic mathematics. Let's use the solver tool now to set a bunch of constraints. Okay, so to use the solver tool, I'm going to go to my data tab, click on the solver add-in, and we can set our objective accordingly. Okay, so remember, what is the objective? We want to maximize profit. So I'm going to select my total profit as the target cell. Okay, and I'm going to leave everything as, and I'm going to say set the objective by changing which cells. I can change how much gas is produced. So I'm going to highlight these two cells. So we see B4, C4. And now we're going to say subject to the following constraints. So this is where we put in our constraints, which we've done previously. Okay, so let's add some constraints. So we click the add button and we should get a cell reference. Okay, so firstly, we can only make real values of the gas. So the cell reference B4, so the total produced ton, must be greater than or equal to 0. Okay, I'm going to click add. Okay, and we do the same for premium. So that must be greater than or equal to 0. Click add. All right. So now we add our other constraints here. Okay, so remember the only available cubic meters per ton is 77 for both regular and premium. So I'm going to say this total amount here must be less than or equal to, and my constraint is going to be what is available. Click add again. All right. Do the same thing for our production time. So we only have 80 hours. So the total production time must be less than 80 hours. All right, click add. And then I'm going to say the storage for the regular, that is this amount, must be less than or equal to our constraint, which is the storage available. Click add. Storage premium must be less than or equal to our constraint here. Okay, click add. Okay, that's fine. It's just going to give me a warning, but that's all right. Let's click cancel. So we're back to our solver parameters, and you can see from here, we've set up a bunch of constraints. Okay. We're going to use the solving method, GRG nonlinear. So I mentioned that in the previous discussion about nonlinear methods. Okay, and we're going to hit the solve button and let's see what we get. Okay. So that doesn't seem right. There we go. It's working through some solutions. All right, we've got a solution. So let's say keep the code. Well, firstly, we can save this scenario. So if we click save, we can call it raw gas production. Okay. And we can either restore our original values or keep the solver solution. I'm going to say, okay, I want to keep the solver solution. And what you should notice is that our values here, so let's just highlight this, are equal to what we found with all of our other solution techniques, the optimum of the solution. So that's how we can use Excel to optimize a simple problem. And yeah, so the advantage of Excel wins the game.